So let's start the first slide. So my first question that I'm like to ask from you all is like, anyone can answer, how do I select a machine learning algorithm? What are the factors that I need to consider when I'm selecting a machine learning algorithm? Anyone willing to answer that question? I know this is the topic of the presentation, but I like to make it a discussion so we can participate and we can go further. Okay, then there you go. Actually, there is no straightforward answer or sure shot answer that we can tell. Like, using this algorithm or this kind of algorithm, we can get the final output that we are expecting. But that answer, but solution to that problem depend on many factors, like problem statement. That means what kind of problem we are planning to solve and what kind of output we need. And also the type and size of the data set. But the data set is very important. I will discuss about it further in the slides. And the computational power, what kind of computational power we have. I mean, like, can we train our data in real time, or can we get the required output by training, and number of features to name a few. So let's see how these factors help us to select a machine learning algorithm and how we are going to train a model using considering these factors. Having said that, I like to focus on main 3 points, and I like to explain you main 3 points that we need to consider when we are trying to solve a new problem. First is like, you need to have an objective of the problem. So like, when you are solving problem, you need to have a focus. Okay, there is an issue in the industry. There is this kind of requirement in the industry. So I'm going to solve this. This is my objective, right? Without objective, we are not going to do anything, right? I mean, like, having objective doesn't necessarily means that you need to have a final output goal. I mean, like, you can get a final output which is not satisfied. That means your research will not work as you plan, but it's okay. That means you are showing to the world, okay, for going through this step, you cannot achieve the final target. So you are showing to the world like, okay, eliminate this step. That is also a research. And also, if you got the final output, you can say, okay, I got the output, and following this path, these objectives, I can get this final result. So always you need to have an objective in order to solve a problem. So that is the step 1. Second step and fourth important step is like, familiarize yourself with the data. So you need to understand what kind of data you are going to use your project, and do you have sufficient data. Let's discuss further about this step as well when we are going through the presentation. And third step, start with the basic model and try to achieve your objective. With a basic model, you will obviously not get the very accurate model. So with the basic model, try to map your inputs to outputs. Once you build your baseline model, try complicated methods, complicated algorithms in order to improve your model. So let's discuss further these things and how we are going to consider these factors when we are going to build a data science project. So in this research presentation, the main topic is like selecting algorithms and machine learning practice. So I thought to include some, share a little bit knowledge about machine learning with you all. So machine learning basically can be divided into 3 parts. First one is supervised learning. Second one is unsupervised learning. Third one is reinforcement learning. Basically, here I will talk with you about supervised and unsupervised learning. So what does it mean by supervised learning? Supervised learning means like when you can map when the algorithms analyze the input data and learn a function to map the relationship between inputs and output variables, we called it supervised learning. Supervised learning are, for example, classification, forecasting, and regression, those kind of things are supervised learning. Unsupervised learning means like unsupervised algorithms trying to find the instinct pattern and a hidden structure in the data. For example, clustering and dimension reduction can be categorized as unsupervised learning. To simply put, the difference between supervised and unsupervised learning is like supervised learning use labeled data, which we tell, okay, we tell the supervised model these kind of data we are going to use. Unsupervised learning learn from the data. So, so this is the basic parts of the machine learning and main parts of the machine learning algorithms. So I thought to discuss a little bit more about that, so you will know a little bit more. Okay, so in the beginning, I told that I'm going to make this presentation because like I will not discuss many theories with you all. I will discuss a practical problem I did, so I can explain to you all what are the difficulties I face, what are the what methods I follow in order to achieve my objectives. So you can see there are two cube satellites in these two videos, and you can see one is a 1U CubeSat, another is a 3U CubeSat. And also you can see that like each CubeSat, it has its own bounding box, the red color box, and it is labeled whether it's 1U CubeSat or 3U CubeSat with a probability. We all know probability range from 0 to 1. So have a good look at this video. So I will discuss few things during my presentation and future slides. And if you look at the first video, the 3U CubeSat, where you can see when the antenna is opening, it gives two probabilities. One time it says 3U CubeSat, other time it says 1U CubeSat. So let's see why it's happened and what are the issues here and how I overcome these issues. Okay. So like I said, I told 3 steps that we need to follow when we are doing a data science project. First one is we need to have an objective. Second one, we need to understand our data. Third one, start with the baseline model. So in order to develop a CubeSat detection model, I had the objective. The reason is there are more CubeSat launches increasing day by day. All over the world, people are launching CubeSats. This caused the increase of small satellites in lower Earth orbit, which caused to increase the traffic and possibility collisions between satellites and asteroids. So it requires more service missions to remove debris. So I thought, okay, this is a good opportunity if I can build something that we can detect CubeSat in close proximity and make the autonomous vehicle to understand its surroundings. So I came up with my objective. So that is my objective. So once I finalized my objective, then I came up with my research question. Okay, how can I develop a system to detect CubeSats in close proximity? So once I've finalized with my research questions and objectives, I did some preliminary research. Preliminary research means like I read about it. Okay, are there available things in the industry that I can use? What kind of things are available to detect CubeSats in close proximity? And what kind of algorithms can I use? Right? And like what kind of data available? When it's come to data, for my case, it was images. But if in your case, the data can be categorized like if you're planning to texture, you will have to learn about natural language processing, like Google texture, or voice activation. The data will be like for voice, like voice product will be Alexa, Siri. These are voice activated data, right? So second step, I did preliminary studies to understand my data. Then I realized like, okay, there are no much data available in the, there's no such a close proximity detected CubeSat in the industry. So in order to do this project, I need to collect data. So that is a very critical and very important part. So I will discuss it later in the presentation. So then I started collect my data and I moved to my next step. I will discuss about data and it's important in future slides. So I did my preliminary research and came up with my, I did my homework actually. So third step in my, when I started the presentation, I told like, okay, after objective and collecting data, build a baseline model. So after doing my preliminary research, I understand like in order to develop this kind of model, I will need to use neural networks. So because like it depends on my output. I needed the output with which I can map with the input, and I needed like in order to map the inputs and outputs in machine learning, I choose to use the supervised learning algorithm. So supervised learning algorithms means neural networks are supervised learning algorithms. So I choose a neural network. Before go further, then I thought like, okay, I need to learn fundamentals in order to build a complex model. So I came to the very basics of a neuron and I tried to understand how it built. It's built neural network, as you can see in the slide, it's neural network built with the neuron cell. So left side, it says the neural cell of a brain, and right side, it shows the mathematical model. So in a neural cell, we get inputs to dendrites, and it's passing through axons like nerves, and it's passing to another neuron. Same as in a mathematical model. So if you look closely in this mathematical model, you can see there are few inputs from x1 to xm. And there are some weights, W1 and W2, W3. So what does that mean? Let's try to understand this basic model. So in that way, you can apply, you will try to learn your basic, whatever the projects that you are planning to do. So here we have input from x1 to xm, and we are assigning weights from W1 to W8. That means like we use priorities. For example, think like I'm planning to build a CubeSat detection model, and images who has CubeSats, I'm giving higher weights. If it's x1 is the CubeSat, I'm giving higher weights to W1. If it's not, I am not giving. So after that, we are taking the summations of all inputs with the weight and adding a bias part for this input summation. And after that, I'm passing this information through an activation function. That means like if the required output is there, give me a 1, otherwise 0. If it's activated, I'm going to detect it. It's like, okay, there's an object of interest there. So name it or draw some kind of bounding box or something. So this is the very basic. So in my last third step, I try to build a baseline model before I go for the complex model. So once I built my baseline model, then I try to search what are the complex model available where I can get much more accurate. So again, I was researching on an industry and I was trying to select algorithms, and I came up with these 3 algorithms, which shows promising results. First one is RCNN. Second one is fast RCNN. Third one is faster RCNN. There are other objects as well, like, other object detection systems as well, like YOLO, like, very accurate systems. But I was limited my research to these in order to see whether I can achieve a final output, because my data set is very new and I don't know how my data set will react in these architectures. So doing further research, I understood that fast RCNN is the best model among all the other 2. So I choose fast RCNN. So what happened in fast RCNN is like, it has an image. That image is passing through convolutional layers and giving us a feature map. And after we get the feature map, we are trying to get proposals. That means whether there's an object or not. In my case, whether there's a CubeSat or not. But in this stage, it's not going to find out whether there's a CubeSat is there or not. It's trying to find out whether there's an object or not. And it's passing through the final layer and do the final classification. So once I understand about this fast RCN architecture, I thought like, why not I am trying to modify this architecture and try to understand, try to improve this architecture so I can get better results for my data. Because like this architecture is like model for a particular data set called ImageNet. So it's a very famous data set, very higher accurate data set. So I don't know whether this architecture will perform very well for my new data set, because I am creating my own data set, right? So when I am training, what I did was like, okay, I tried like, okay, this convolutional layer, this layer, I can change it. I can modify it as my wish. So I thought like, okay, let's not stick to the same architecture which they are proposing. Let's propose new architectures and let's try other architectures are there. Okay. So at a point I decide, okay, no, I'm not going to use any of these architectures. I'm going to build my own convolutional layer and come up with my own feature map. So that is called research, right? That is called like, you know, we are trying to learn something, research. It might work, it might not work. If it's not work, I know, okay, I can eliminate this method. It's not going to work with my data set. So what I did was like, I tried to change the architecture, convolutional layers, and I tried to build my own model to get the feature map. And then when I'm further studying about this architecture, then I realized, okay, this region proposal network is very critical because it's trying to decide whether there's an object or not. So what happened if in this region, if it's failed to find the object, then my final classification obviously wrong, right? Because like at the middle step, it's eliminating all the possible objects. So then I decided, okay, let's try to make more modification to this layer and try to improve the object detection. So here my main target to explain you all, like you can, you know, like once you select your data set, once you decide your data set, and once you familiarize with your data set, don't stick to an algorithm because like that algorithm may not be the best algorithm. Try to learn the basics and try to modify the algorithm, right? Because like we cannot say all the algorithms are good, all the algorithms are good, because there are some algorithms, some algorithms fail. Sometimes they are failing. I mean, like there are no 100% accurate. Like there are some, but like we cannot always predict like, okay, this is 100% accurate for my problem. So to your problem, you always have to study and understand it. So here I came up with my own design, and I feel like, okay, I need to focus on this RPN layer, and I need to increase the object proposal in order to get my high accuracy for my new data set. So I made some modifications. So my main motivation for you here is like, no, when you are selecting algorithms and when you know the fundamentals, try to improve the architecture to see whether it's working. Sometimes it will work, sometimes it will not work. So like I said, it's research. Every research matters in life. There, you cannot say like this is a bad research, this is a good research. Because like if you take Apple phone iMac Pro, it didn't build overnight, right? It took long researchers to research to build what we have today. And also still today they have bugs. Sometimes they do software updates, right? That means to fix the bugs. So always do good research and focus on what you are doing. So you will have great research, and you will, end of the day, you will have great satisfaction as well if it's not work. Okay. So I discuss all three steps that I did for my project. First one is I came up with the objective with a research question and I found my objective. Second, I collected my data, which I told I will discuss later in the slides. Third one, I learned the baseline model and I built my model, and then I went to complex model, and I didn't stop there. After that, I tried to modify the complex model in order to algorithms in order to match for my data to get the better results. So let's discuss how's my results was. And before that, let's discuss data, because I told I will discuss about my data with you all because data is very important. So in my case, I selected a new database because there was no data set available for CubeSat detection. So what I did was like actually my professor, he helped me in collecting data with by contacting his aeronautical professor. So he contacting like some reputed companies and other sources. He helped me to build a good data set. So once I collected my data, the first thing is I did was like try to understand my data. That is because data is very important as much as the algorithm when you are doing a machine learning project or data science project. The main reason is like think that you have poor data and you have perfect algorithm. If your data is wrong, even how perfect your algorithm is, you will not get the not get the required output, right? So you need to focus on data and understand the data. For example, like, you know, some data you can find linear data where you can use like, you know, linear regressions or Naive-Bayesian theorem or linear SVM where it will divided. You can divide the data like this is like, you know, by drawing a line, this is that. But sometimes it's not always the case. Most of the time when you have to deal with data, it will be non-linear. So you will have to choose the algorithm according to that. So like sometimes you will able to find a sufficiently large data. If that's the case, you can again go for a different algorithms. Like, you know, you have to go like, you know, data with high like, you know, like support vector machine neural network when you have sufficient large data, and like with the linearity also. The second step, once I collected my data and once I cleaned data and eliminating all the bad data, first second step I did was like I divided data into two parts, training and testing. Always make sure you will not, your test data set is unseen to your algorithm. Because like otherwise you cannot validate your model. If you like, you will get higher accuracy if your test data also the same as the test data is subset of a training data. So always make sure you will separate at the very beginning when if you are going for a new data project, if you are going to select a new data, always make sure you will separate your training data set from the testing data set. And like when you are selecting, when you are trying to do a model or algorithm, try to understand the bias and variance. What is bias and what is variance? So model with high bias pay little attention to the training data and overly simplify the model. So you need to understand like, okay, what kind of bias is my data? Like, you know, because like bias is like, you know, if bias is very high, it will pay low attention to the training data. And what will happen? If you see this graph, you can see high bias data, it will underfit your training final output. What does it mean by underfit? Underfit means like it will not what you expected. The results are far way low than your expectation. And what will happen if you have a high variance? When you have a high variance, it pays lot of attention to the training data. And what will happen? It will overfit. If you see the left side graph, you can see all the points are connected to each other. That means it is high variance. That means like your model is like, if you are expecting 90% accuracy, your model is giving 100% because the data is already overfitted. That means again, your research is like, you know, wrong. Having 100% accuracy doesn't necessarily mean you train a good model. It is overfit. Sometimes it can be an overfitted model. So make sure you will avoid the underfitting and overfitting. So in order to avoid the underfitting and overfitting, you need to understand your data and train algorithm accordingly. Good models we consider low bias and low variance, which combines the data and we get the expected output. Okay. I'm talking a little bit more about data because data also much more important as the algorithms. So data cleaning is considered as the secret ingredient of any data project. So this is only applicable if you are going for a new database like me. But if you are not going for a new database, if you are planning to use the existing database in the internet, and if you are trying to use that database to train an algorithm, then you must need to focus on algorithm. But it's again depends on what kind of inputs and outputs that you are expecting. So it says better data often beats fancier algorithms. So if it's a new project, always make sure you will have a clean database and a sufficiently large database. I mean, like sometimes data will be, when you are collecting, for my case, when I'm collecting the database, there was no enough data. So what I did was I used data augmentation techniques in order to improve the database, like to increase the number of data. Like I use some kind of data augment techniques to maximize my data so I can train. But if you have a small data, when it's come to neural network, like artificial intelligence neural networks, you can do something called transfer learning. That means like you have a small number of data, but you have a very well trained model with a huge number of big data. So what you are going to do is like you are going to use that very well trained model in order to train your model. So that we call transfer learning. At one step, I had to use transfer learning in order to make sure that I have the correct output. Because like when you are doing a research, you have to see all the possible ways. It's not it's like don't follow a singular path. Okay, I am following this singular path to achieve my objective, right? So always focus on wide areas, and like always focus on the possibilities. The final step that we need to focus on the accuracy. So now you think like this. Okay, I have an objective and I've collected a really good database. I clean everything, or I use existing database, and I built my baseline model, and I develop, and then I went for a complex model, and I developed my algorithm, and I got output. That doesn't necessarily stop your research. You need to show to the world, okay, this is how much accuracy I have. In that way, you can tell like, okay, this is not accurate, so I'm going to eliminate it. That is also a research that you can tell to the world. Okay, don't follow this path. If you follow this path, you will get stuck, right? So always pay little more extra attention to your output accuracy and show to the world, like what kind of accuracy you got. And when you are doing your accuracy, select your metrics in order to check your accuracy. So in my case, I choose precision and recall curves. So this is object detection computer vision problem. So in this precision and recall curve, what I was trying to find was I was trying to understand how many true positives to all the number of testers, and how many true positives to true and false negatives. So you can see the equations. So what does it mean by true positive? So this is the thing. This will not exact the same what you all planning to do for your project. What I am trying to do is here, like, okay, take one example and show all the steps that I follow to that one, so you can use that to your project. So I think rather than discussing a theory, I believe this will, in this way, it will make you much more understand what to do, what to not to do when you are doing a data science project. So true positive means like a positive that like, okay, if I want to detect a CubeSat, and if my algorithm, once I feed the input, if my algorithm detect the one new CubeSat, it's a true positive. So can you remember in the beginning, I told you to pay a little bit extra attention to the first video. When the first video, the 3U CubeSat, when the antenna is opening, you could see that like there were like two CubeSat. One time it's detected as a 1U, and one time it detected as a 3U. But there were probabilities. A 3U CubeSat with the higher probability, like 8.89 something, and the 1U CubeSat with 0.3% probability. So in that case, you can define your thresholds. Okay, my output, I'm going to decide if it gives more than 80% accuracy, I am going to consider it as a true positive. So you can eliminate the other output. That means, what was that one new CubeSat detection in that video? It's a false positive, right? It detected, it was not a 1U CubeSat, it was a 3U CubeSat, but it gave me a probability. So with the precision, I was trying to calculate how much false positives I got and what is my true positive percentage from that. In that way, I can get the idea, okay, this much of false positives are there. And second one, I was trying to learn about recall. In recall, it is again to true positive, the ratio between true positive to true positive plus false negatives. What does it mean by false negative? False negative means like there is a CubeSat, there are no CubeSats, but like it's detecting as a CubeSat. That means a false negative, right? So I am trying to learn about precisions and recalls in order to get my outputs. Then I plot the graph, because like graphs are always a good way to show your research to the world, your accuracy to the world. But sometimes you can use different accuracy measurements. Like, you can use, according to your data set, you can use like, so if it is support vector machines, you can use softmax functions. It depends on your data set and what are your expectations. So always choose the algorithm, choose the metrics which shows your accuracy very clearly. I mean, like, no point of hiding your research from the world, because like you can trick it that, but end of some point it will come out. So always select algorithms or metrics which you can show your results very accurately. So that's why in this case, other than my videos, I use like some other pictures to make sure that I got the output. So the first one and second one, we considered them as like hard problems for computer vision, because like second one, you can see the lady is wearing a similar texture to the 1U CubeSat. And first one, you can see there are multiple people are there, like many people are there, but it's accurately detect the CubeSat with the high accuracy, like 0.89. Obviously, like if it's like it will be a four like if it's like detecting a person's head as a CubeSat, that means it's a failure, right? It's a big failure. So always make sure you will test your results accuracy in multiple ways. For example, like for me, I was tested using like matrices, and again I was showing it visually. Okay, this kind of accuracy I can get. So once you're done with the accuracy and everything, another thing you need to consider when you are training a CubeSat, any kind of data science project, how much computational power you have, and how big is your data, and how to train your data. I mean, like, if I understand that you all are going to have a competition, right? So what's the purpose of having a very accurate model if you cannot have your results by the competition date, right? And it's good. Obviously, you can do research and you can do the publication, but here we have objective. We have objective by this date. I need my project to be completed in order to participate in this competition. So always make sure you will have enough computational power and training time. For if you are going for a neural network problem like mine, you need to have a high computational power, because like at that point you are using big data, right? For example, if you take like newest models like like iPhone Pro, iPhone 13, iPhone 12, they have the face detection system. Like they train a new face. Like if you brought a new phone and if you want to train your phone to detect your face, it will train within less than a minute, right? That means like that's what happens is it do a transfer learning. It has a big data which already trained for face detection system, and whenever new faces comes, it use the latest technology and transfer learning and train the new face. So it will detect accurately. And always it is very accurate, because like I never heard a case that like iPhone will open other phone for like, it will fall detection. Fall detection is very low in iPhone face detection. So always make sure about the speed and computational power you have, so you can choose your problem accordingly. End of the day, like you choose to do a computer vision problem, but you don't have enough computational power. So all your effort will be a waste, right? So like algorithms like Navin, Bayesian, linear, and logistic regressions, they are easy to implement and quick to run, because they don't need much like Monte Carlo problems. They don't need much computational power. But like algorithms like support vector machine, neural network, they have a lot of parameters to tune. Okay, this is also another important factor. When you are training, like when you are doing a new database or when you are using a new algorithm, you have to make sure that you will train your network and tune your parameters. Sometimes, my problem I am showing to the world, like with the parameter tuning, I got my final output. That means like I train it multiple times. Like with, for example, parameter training is like number of data is a parameter. Increasing, obviously always increasing number of images is good for this kind of problem. And sometimes there are other parameters, like the algorithms comes with its own, like weight, some alpha, beta, gamma, for those kind of parameters. So you need to tune these parameters in order to get your final outputs, accurate outputs. So always make sure you will have further. Can I improve this progress? Can I improve this process furthermore? So then I realized, okay, my model still gives me like errors. Like sometimes my I took another measurement called mean average precision, where I took the mean average of all detection results, and then I realized sometimes my model gives like 80% accuracy, 90% accuracy, which I was like, okay, that means there are 10% of fault detection, right? Then I'd like, let me see whether I can reduce this fault detection. So that one I did further research, and I came up with my own method, which I named two-step verification. Where what I did there was like I use my results and I combine it with theory of evidence. Jaeger theorem, Dempster-Sheffer theorems are very famous theory of evidence, and I built my own database for this project. Earlier, what I did was like I collected a database. With my professor's help, I collected a database to get the output. In this case, I built up my own database using CAD modeling. In that case, so in this case, I could increase my classes from 1U, 3U CubeSat to another 2 class. I added another 2, 1U, 3U, 6U, 3U CubeSats. So so then what I did was like, okay, I made a sufficient data. I mean, like you can see, I made like 90K, more than 90,000 images with random views with 30 appearances, because textures matter when it's come to computational problem, computer vision problem, my case. And I made sufficiently large database to combine it with theory of evidence to get the required output. So that means like after you done your research, you can further see like for more improvements. Like okay, let's try to improve the results more. Because like current model, it's have some difficulties of detecting its gives fault detection. So let's try to improve it more. And after that also, like I thought, oh, further, can I improve it further? Can I do more research on this? Then I decided how, like when a CubeSat is going, when a space service machine is going in the space, and how if we can use these detection results to estimate the attitude of a spacecraft, it will be again helpful, right? Because like spacecraft, it's by once the how it can be helpful. It can be helpful when the primary fails, when the primary attitude estimation fail. If the aircraft can get track the out understand its surrounding and try to get the understanding about its understanding about the surrounding and get some kind of algorithm to calculate its attitude, it will helpful for the spacecraft. That means it's a secondary attitude estimation method. So what I did was like I again did a simulation model. I created a simulation model with the camera pose, because like how my plan to do is like, okay, understand the environment through the camera and estimate the attitude. And in this case, what I did was like I combined the results of my computer vision problem with a very famous problem called Wahabas problem. And I tried to solve that Wahabas problem in order to determine the attitude, and I was able to determine the attitude of a satellite using the detection results of a computer vision problem. So that means when you start to research, when you know your fundamentals, and when you understand your data, and when you do your all preliminary research, you can do a lot of research. Once you achieve your final target, you can further move in many directions and do many research. So always remember that, like once you come for your final goal, don't ever stop there. Like, okay, I have my final output, I'm going to stop here. No, that will be another point for you to begin, right? And do many other researches. And finally, so this is the algorithm I came up with, and I like, okay, I propose my own algorithm. See how it developed. Earlier, I had a very low knowledge about the data and everything, but I start with my objective. I collected my data and I do the baselines, and I develop a complex model. Now, in final step, when it's come to that, I came up with my own algorithm, and I develop my own algorithm, which will help to satellites to detect the attitude estimation when primary fails. So always focus on the research. Finally, whatever the competition when you are participating, my advice is show your limitations. So okay, this project is this is what I came so far. This can be further improved in these ways, and give the society, to the computer vision, like other data science community, to do research something. Okay, I have this kind of limitations, and this kind of limitation with my problem, right? And like let them to research furthermore, or make it like, you know, for yourself, like you can do further research on that one. So these are the basic steps and basic things that you need to follow when you are doing a data science project. I hope I mean, like I took like 1 hour from you guys today, so I hope I was able to give you some knowledge about a project and how to do a project, how to select the data, and what are the important things need to be considered when you are doing a data science project. So if you all have any questions, feel free to ask. Hello.
Yes, thank you, Dr. Indika, for the very interesting session. I'm pretty sure our audience had a lot to gain from it, just like I did. And we will now be opening a Q&A session. So please feel free to ask any questions you may be having on the chat box below. You can also use the raise hand option and ask a question yourself once I call out your names. So now you can direct your questions to Dr. Indika Gamage. Dr. Indika, Rajita has directed question. He has asked, previously you mentioned about the algorithm customization. So when we are customizing our algorithms accordingly, what are the factors that we should concern?
Yeah, that is a very good question, Rajita. So when you are customizing an algorithm, like it depends on your algorithm. So like, you have to choose what kind of factors you can change in that. For example, for neural network problem, like, you can change the way, you can change the like number of layers. Right. So for example, like, there are like in a neural network, it's passed through like ReLU layers, activation functions, those kind of things. So you can customize those kind of things and introduce new layers, or you can introduce new activation functions. So it's all depends on your algorithm. For example, think like, you are using a Monte Carlo problem. So Monte Carlo problem is a probability, right? So when you are customizing, you can customize the input, like, Gauss, you can, rather than giving a Gaussian input, you can use another type of input. So it depends on your architecture, and you have to focus on your architecture. What are the parameters that you can tune? Some parameters are the fixed parameters. Tuning these parameters will bring you for a disaster, right? So always understand your algorithm first. So I can give you one baseline example, like, convolutional neural network. For convolutional neural network, you can change the layers. Obviously, you can change the layers, because convolutional neural networks, there are many architectures like PGG16, ZF, Google Net, which with heavy, which they use to do adding many layers, removing many layers, adding many activation functions in order to improve that. So when you choose your algorithm, always focus on the what do you call changeable architecture. Some architecture, some parameters are there; they are fixed. You cannot change those things. So always understand your algorithms and see whatever you can change there. Does it answer your question?
Yes. And then Savin Pereira has asked, when we are creating our basic model, what are the testing methods for the testing the model?
Yeah, so like I said in the beginning, when you are creating a basic model, always make sure you have a test data set and train data set, and you build your base model using the training data set. And always make sure your test data set is not used in your inside your training data set. So if you like, for example, like computer, again, I will take it from a computer vision problem. And if you have some face detection system, and you want to train a model to detect a particular face, right? Always make sure that like that face is not there in the that face is not there in the main training model. So it will come as a new face, right? So it will not like, like it's already inside the training model. So it will like, faking it, like give you 100% accuracy, right? Like, for example, think that you want to train a face detection system for myself, for my face. So I am inputting large number of images to the training, but I also want to make sure that there are some test data sets that algorithm never have seen. In that way only, that it can track, you can get the idea of accuracy of unseen data, right? Okay.
Okay, sir, thank you. And then Chetana Rupa Singh has directed, what is an AutoML? I saw some articles regarding that. Can we use it for create our model?
Yeah, AutoML means like it's a machine learning model again, right? So you can use obviously this to create your own model. Yes.
And then Mitmi has asked, is machine learning all about try to understand algorithm?
No, it's understanding data. It's understanding your data as well. I would say that, because like algorithm means like machine learning. it's like there are different algorithms, but at the same time, data, speed, understanding, accuracy, everything is important in machine learning. Okay.
And then Madara Palyakkaras asks, is there any self-studies learning material for machine learning that you can recommend for us?
Yeah, so there are a lot. So I will recommend mainly Andrew Nick. So you know about Andrew Nick, right? So he has wonderful courses, right? From machine learning to NLP and object detection, everything. He has very wonderful courses. So I strongly recommend, because he is the very strong researcher in computer vision machine learning, right? I strongly recommend his self-study materials, which are presented very easy to follow away. So I recommend that one. And other than that, like if you go to the internet these days, everything is available on internet, right? So you can easily, but my recommendation is that one, it is very easy to follow. I understand majority of you are like undergraduates, right? So that's a good recommendation. And other than that, do your research always and focus on, like, your data sets, and always like, in machine learning there's no free lunch. You have to do everything from the very basics and learn everything and go to the next step. Okay.